Hello statisticians. I wanted to make a video today about round-off error and how it is leading to wrong answers in WileyPlus homework and how to minimize it and get the right answers in homework and in life. So what is round-off error? The term error means different things in different places of math. I mean, it could just mean that like you made a mistake. Sometimes an error is just a mistake. But the term error can also refer to how much something is different from the true value. So there's like standard error is like a measurement of how much different sample statistics are from the true population parameter, for example. But round-off error is how much your answer is different from the exact answer due to rounding. So a quick example here is the square root of 2. The square root of 2, if you type it in your calculator, is going to give you a whole bunch of decimal places, and the true value of the square root of 2 is an irrational number. There's going to be a bunch of digits that kind of go on forever, not repeating themselves, and it's impossible to write down all of those different digits. So you might round your answer to 2 decimal places, and you might write down the square root of 2 as 1.41. That's an approximation, and that's okay. It's still right, but it's not the exact. I mean, this would be like the right answer in a homework problem, because usually they say to round it off to 2 or 3 decimal places, but it's not the exact square root of 2. And the amount that it's different is the round-off error, how much of those decimal places you lost. And that is 0.00021356 is what we mean by round-off error here. So I want to show you how round-off error can lead to answers being really wrong in the end. So I sort of came up with a contrived example here of a question that you might have in the homework, although this isn't really a homework question, but this is an example that shows you how round-off error can make things really bad. So there's a few ways you could do this. We're going to do 1 over the square root of 2 squared minus 1.9. So the first way is round off to 2 decimal places at each step of the calculation. And we're going to see why this is going to lead you to a pretty much wrong answer with more round-off error at the end than you want. Method B is round off to 5 decimal places at each step. And method C is do as much calculation as possible at once in one line of your calculator to use all the precision that your calculator can store. Okay. First of all, let's just go over how you could do this without any calculator at all. If you just notice that the square root of 2 squared cancels out, so the exact answer for this would be 1 over 2 minus 1.9, which would give you 1 over 0.1, which is just 10. So 10 is the exact answer without using a calculator at all. So that's what we should get. And then this one, example 2, is the same thing but with a plus 100, so this should give you 110. Okay, so that's the exact answer. Now let's see what happens if you do method A here. So example 1, using method A, we're going to do the square root of 2 is 1.41. So if you do 1 over 1.41 squared minus 1.9, and then I'm going to take my calculator here and do 1.41 squared is 1.988. And then do that minus 1.9, and that's going to give you 1 over 0.088. And with the calculator, that's going to be 11.36 after you round off. So what is happening here is when you take a rounded off error and then you square it, the round off error becomes even bigger. At this point, the round off error is about 0.012. That's how far off this is from the square root of 2 squared, is how far off it is from 2. And then you subtract it, you still have some round off error. This should be 0.1 in the denominator, and then 1 divided by that gives you 11.36. So now, at this stage, the round off error is 1.36. That's how far off this is from 10. So that's going to give you the wrong answer in WileyPlus. I also want to talk about WileyPlus error tolerances. So WileyPlus allows you to have answers that are off by 2% of whatever the true answer is. So 2% of 10 is 0.2 here. So if you have anything between 9.8 and 10.2, it will mark it right. But if your answer is that you put in the box is 11.36, that's off by too much, so it's going to mark it wrong. And then if you do example 2 here using method A, you're going to get you're going to do all this calculation the same way, but then add 100. You're going to do 11.36 plus 100 is going to be 111.36. Now, that, if you put that in the box, that is within 2.2 of 110. So WileyPlus would actually mark this right. So this is another why you're getting some answers wrong in WileyPlus, but other answers right. It's because you have some kind of error. You're off by a little bit. And if the answer is a smaller number, like 10, then 2% of a smaller number is a smaller error tolerance. If the answer is a bigger number, like 110, then 2% of 110 is a bigger error tolerance, and it will mark it right. So, anyways, so that's what's happening with those. Now let's go over how to do this right. The right way to do these. So method B says round off to 5 decimal places after each step. So if you were to do the square root of 2 here, and you'll get 1.41421, and then you do 1.41421 squared. That's going to give you 1.9999. I'm going to write that in here. We're doing 41421 squared minus 1.9. That gives you 1 over 1.99999 minus 1.9. And then after you subtract that, we're going to get 0.09999. And if we divide that, we're going to get 10.001, which is a perfectly close enough answer. So rounding off to 5 decimal places is good enough. Okay, so, and then with method B, with problem B, of course you'd get, I meant problem number 2. Oh gosh, I called this A. I meant to say we're doing method B here. I got mixed up. I I hope that wasn't too confusing. So for problem number 2, using method B, you would do the same thing. You get 110.001, which is close enough. That would work. All right, now what is method C? C is my favorite as somebody who studied computer science in college, because doing as much calculation on one line of your calculator is a little bit like programming. So what we're going to do here is just the whole thing in one line. 1 divided by the square root of 2 squared minus 1.9. Just write it all out at once, and then your calculator is going to do every step of this calculation, keeping all of the, like, however many digits it's storing along the way, and you're going to get an answer that's very, very close to the right answer. So that's really the best way, in my opinion. Okay, so yeah, that just leads you to 9.9999, which if you're going to round this off to however many decimal places, it's just going to be 10.0000, unless you round it off to like 12 decimal places. You write it as like what we have here. Okay, so anyways, that is how to avoid round-off error in WileyPlus. I think method C here is the best. Just do as much as you can in one line of your calculator. If you're not going to do that, then do not round off to 2 decimal places at each step. Round off to more than that, like 4 or 5 or 6 decimal places at each step. And then your answer is going to be close enough at the end. All right. Thanks for watching.